today we're going to learn about air pressure. Air pressure, it could be helpful or harmful. Air is all around us. It's pressing on us right now. In fact, 14.7 pounds per square inch is on your body right now. So 14.7 pounds per square inch is this small. And here I've got about 15 pounds of books. And if you can imagine this much on this much of your body all over, that is equivalent to about 1 ton of pressure all on your body, like the size of a small car. We don't actually crush under the pressure because we have air inside of our bodies. Our lungs and other organs are filled with air. The same pressure that's on the outside of your body is also on the inside of your body. So the forces equalize. So there's 14.7 pounds per square inch going into your body, and there's 14.7 pounds per square inch going out of your body. There's high pressure air and there's low pressure air. The high pressure air always wants to go to the low pressure air to occupy its space. Just think of a bully. The high pressure is the bully and wants to pick on the low pressure. Inside of our lungs, when we need to take a breath, there's low pressure. That's why it's easy to take a breath, because remember, high pressure wants to go to low pressure. So when we need to take a breath, the high pressure outside rushes in to our lungs, which is the low pressure. Now that you know about air pressure, let's do some experiments. The first one is we're going to get a cup full of water all the way to the top. We're going to get like an index card, and then we are going to put it at the very, very top and make sure that the rims are underneath. Very, very important. All right. So I'm going to turn this upside down, and you tell me what you think is going to happen. Do you think that this index card is going to hold the water inside? What do you think? Voila. So what's causing the index card to hold onto the card? Well, remember I told you that 14.7 pounds per square inch is all around. Air pressure is all around. So air is pressing onto this index card and causing it to stay in place. For our next experiment, you need a plate, candle, match, cup, and colored water. First, you light the match. Then light the candle. Make sure it's lit pretty good. All right. Okay, then we put the cup over it. Put some water inside, and I like to have it colored so that you can see. There you go. All right. So what's happening is the flame is using up the oxygen, which is causing the air inside the jar to become low pressure. All right, you see that? Do you see the water? The high pressure always wants to go to the low pressure. So the air outside the jar is pushing the water inside the jar, which now has low pressure. For the next experiment, you'll need a jar, a water balloon that's bigger than the hole, and some matches. So I'm going to light these matches and put them into the jar quickly. And we're going to see what happens. Well, it's the same concept as before. where the flame, oh, here it goes. Oh, yes, keep going. Come on, you can do it. Come on. The flame is taking up all the oxygen, and that's creating low pressure. And so the high pressure is pushing the balloon down, but obviously not enough, but good enough. So how do I get this balloon out? Well, I am going to take this straw and squeeze it on in here. Oops. Uh-oh, now it's really in there. I'm going to take this straw and I am going to create high pressure inside of the jar, higher than what's out here. And let's see what happens. Easy as pie. How many of you think that I can hold this cup without my hands? Well, let's see. I'm going to take a balloon and a cup and blow the balloon into the cup. What do you think? Voila. What happens is the balloon is creating a vacuum. So the balloon is taking up part of the space and the air is taking up the other part of the space. How did this water balloon get in this bottle? Any suggestions? Oh, you think maybe I blew the balloon up and then filled it with water? Let's see. No can do. Why? Well, there's air inside of this bottle, and air is matter. Matter is anything that takes up space. So in this bottle is air, and you can't see it. So it is preventing me from blowing up the balloon. Well, we're going to try it again. I'm going to take this balloon, put it in this bottle, and we're going to see if we can try it again. Let's see. I did it. You think it's because maybe the bottle is bigger? No. Listen. There's a hole here. There's a hole here. So what's happening is when I am pushing in the air, when I'm blowing up the balloon, that air that is in here that's taking up space, that matter, is forcing its way out of this little hole. So watch this. So when I close the hole with my finger, the balloon stays inflated. How is that? Well, remember I told you that air takes up space. So there is air in here, and it is preventing this balloon from deflating. In fact, there's even a hole in here. Wow, pretty cool, huh? So that is how I got the water in the balloon. What's another way that I can inflate the balloon? What do you think? I'm going to try it this way. What I'm doing is I am sucking the air out of the balloon, and it's causing the balloon to have to expand. For my next experiment, you'll need a bottle, put a hole in it, and you'll need a balloon. Blow it up. Twist it. Put it on the rim of the bottle. Okay. Now what we're going to do is we're going to show, remember I told you that air is matter and matter is anything that takes up space. So just because you don't see anything here doesn't mean it's not there. Air is in this space right here. So we're going to take this air-filled balloon and it's going to press the air that's in here and see what happens. A little too much air pressure. Hot air expands. Molecules in hot air are moving around. Just imagine yourself on a hot day and you're all hot and sweaty and you don't want to be touched and those molecules are far apart. Cold air compresses. All the molecules are tightly together. So just imagine yourself on a cold day and you want to be cuddled together because you are cold. Okay, so I'm heating up water inside the can and it's causing steam. It's causing hot air. So the molecules are moving around very fast. But watch what happens when I quickly put the can into ice cold water. So there's steam coming out. And woo! Oh, check it out. Look how thin that is. I mean, it really compressed this can. Wow. And what it's so cool about aluminum is that it cools really fast. I mean, just a second ago, it was boiling water, and now I can just hold it and it's cold. How many of you think that I could make this ball float in the air? Well, let's see. You just saw an example of Bernoulli's principle, which states fast-moving air creates low pressure. The hair dryer is creating fast movement. Fast movement of air creates low pressure. So remember I said that in the air there's high pressure and high pressure wants to go to low pressure? Well, that's what's happening with the ball. The air from the room is creating a high pressure and it's causing it to stay right with the flow of the hairdryer. How do I get this toilet paper to move up? Would I blow this way? Yeah, you can blow that way. But what about up above? Remember, I said that fast moving air creates low pressure. So I'm going to blow on top and see what happens. Fast moving air creates low pressure. So the pressure that's in the air is causing the toilet paper to rise. Why? Because I'm blowing on the toilet paper up here and it creates low pressure. But down here is high pressure. I hope you enjoyed this video on air pressure. I want you to like, comment, share, and subscribe, and turn on that notification for another video that I'm going to upload. See you next time.